Welcome back to Balvikan Bharti. Now, in this chapter, as I said, that the two concepts that I have taught you, on that we will do some few sums so that the concept will be much more clear to you. So I will bring some easy sums so that the concept further more easy to get it. Earlier I already shown you some problem that is instantly that came to my mind that I explained. Now we'll start with the conditional probability, the concept that I taught you before the concept of Bayes theorem. I will come on that later on, but initially I will start with the some regarding that conditional probability. So the first problem was that, and but this is a count of 33 because already I have covered 32th problem, I suppose, in the last video. No, this would be 32. Sorry. Okay. So 31 I have explained already, and this is 32. So it says 10, this is count of 10 numbered card, that means all cards having some digit in it. So numbered card, 10 numbered card are there from 1 to 15, and two cards are chosen at random such that the sum of the numbers on the both the cards, that means we are picking two cards and we are doing the sum of the number that revealing on the cards, and it is coming even. So that is my favorable condition. Find the probability that the chosen cards are odd numbers. Okay, so now this will be a problem related to condition and probability. You may say that this is almost the same as the normal probability that we have already discussed, but thing is that there are two things are happening. One is you are getting two numbered card, there is always a chance of getting even and odd card. This is some kind of straightforward probability if you want to calculate the probability of getting odd or even numbers. That is the one part, but apart from that, that is being extended, the sum of that would be even. So there is always a probability that once you will get some digit card, if you add up whether you get even or odd. So two things are coming together, one getting odd or even cards, and some of the cards that we have received will add up to give you even number. So this is a experiment where in a sample space of picking cards which are a count of 10, so sample space is 10 number of cards with the digits written on that. There are two events, one is getting sum of even, and other is when sum of even is there, that should be made of with two odd numbers. Okay, so now if we just write the formula of that, because we are getting two events, the formula of getting, so my favorable condition is that getting probability of choosing cards are odd numbers. So that means if I want to calculate the probability of getting odd numbers, so I am named it as O. So my favorable probability or condition has to be finding the odd numbers when the sum of the odd numbers is even. So OE I am naming it. So two events are named as O and E. O stands for odd numbers, E stands for even sum, and with the formula we can write O intercept E. That means out of the total event of getting even numbers, that even number can cause due to getting two even numbers also, or getting two odd numbers also, because sum of two even numbers also even, sum of two odd numbers also getting even. So this O is a part within E, that is O intercept E by probability of getting E itself. So that means if I see it like that, even in a sample space, there are two events where E stands for getting even sum and O stands for getting odd numbers. So out of that, this could be the section where the odd numbers that I am getting is not giving a sum of I am getting odd numbers with even numbers, which is not giving even sum. So this part is not the even sum, and this part where the both numbers are odd, these are the odd, but there could be possibilities there are even numbers also. So this part where in the sample space the numbers are scattered such that this part is also a part where odd numbers are getting, but these odd numbers are not giving you even sum. So this is even sum, where this part intercept only giving you both are odd, the numbers who are getting both are odd and giving even sum. This part is not giving even sum, so these are giving odd sum. So the odd sum may be consist of odd and even numbers. Okay, so my choice, if I am not mistaken, this part is not giving even sum. So this part is even sum. My events are what? My events are both odd numbers. So this part, the complete part is odd numbers. Okay, and this part is even sum, getting two numbers. This will consist of even plus even. I am asking about this part only, and odd plus odd will give you even sum, but this part I am getting all odd numbers. Okay, but you can say that if I getting odd numbers, why not this part is getting even? Because getting odd numbers, but this part only I am getting odd numbers. This may possible that out of these numbers both are not getting as a result of picking two cards, these are not coming within this range. Out of this, one is picked the odd, other way there could be another event where I will get only the even numbers, and this combination together is not giving the even sum. So I mean to say, you don't think that in this area, if I pick the two cards, will available the both the cards in this area. This total area are the area of odd numbers, but while we are calculating the results, this is not contributing to produce the sum of even. Only this part, which is a part of the even sum, is contributing to get the even sum of even, and both the odds are coming in this area. In this area only maybe the chances when I pick number, one such number is coming out of this range and other is an even number, then odd plus even will not give you the even sum. So both the result is not coming out of this, which is leaving this part only. Leaving this part will give you two odds number and give you even sum. Understand? So now, as I have already marked, the getting odd numbers is an event. The probability of getting odd numbers is what before going to that, the numbers is marked from 1 to 15 out of 10. So what are the chances of getting even numbers between this range? 1, 3, 5, 7, 9, 11, 13 and 15. These are the chances of, because this is not said which numbers is what, that is ranged from 1 to 15. So 1 to 15, my chances of getting even numbers are 1, 3, 5 and this way. So these are 8 in numbers. And whereas if I think about the even numbers, the even numbers are 2, 4, 6, 8, 10, 12 and 14. So how many numbers? 7 numbers. 1, 2, 3, 4, 7 numbers. So while I will calculating the probability of getting odd numbers, so we can pick only from these numbers if these numbers are available. So we can assume, if not all, there are chances of, because there are only 10 number of cards are there, but the numbers range is given. So I can think of getting the odd numbers, all these odd numbers. So my probability of getting the 2 cards of odd from these chances, 8 numbers of odd numbers. Whereas if I calculate what are the chances of even number, then I can pick from my assumptions, because this is not definitely said. So there could be possible these numbers are available and 2 more even numbers, or these numbers are available, 3 more odd numbers. So I can take all the chances because this is not definitely mentioned. So probability of getting even numbers out of this 7 is 7C2. Okay, so both the conditions are marked as OR because my total number is 10. So I cannot have all these numbers because this will count then 15. But as it is not definitely marked, so I can take this. So the total probability of picking 2 cards where odd or even may come, so these are being clubbed with OR. So that means when OR is coming, so my total probability would be this or this. I am not saying this and this, because then that case the total count will be 15. So my chances, my assumptions will say that if odds of this numbers is there, my probability stands like this of getting odd numbers. If this much of even numbers are there, my probability of getting even numbers is 7C2. So my total probability of getting 2 cards out of the total probable sample space is 8C2 plus 7C2, because this is clubbed with OR, not with AND. So this is my total possible outcome, and your favorable outcome is getting 2 odds. So this is my favorable outcome. So my now how will you use this formula? Getting 2 odd when sum will be even. So that comes when odd intercept even, the even sum. So my probability of odd intercept even sum is what? Probability of odd numbers is this. This is my probability of odd numbers, and probability of even sum is any number I get in the odd 2 numbers will give you the even sum. So that means the total result of, if I consider purely the odd, because here I am picking purely odd numbers. So if I get both the odds number, that is my favorable condition, that will meet the even sum. There is no other possibilities that I will get odd and even sum, because this, if I pick any 2 odd numbers, the sum will be even. So this is my complete favorable condition, you can say. So my O intercept E will be this one, 8C2, because there I will get both odd when even sum will come. This will satisfy the condition, and probability of getting even sum for both the cases I will get, because if I get both the even, also I will get even sum, both the odd I will get even sum. So this is my complete condition of getting even sum. So this is my result 8C2. So that stands for factorial. Now you can calculate yourself, because factorial you know how to calculate. So 8C2, that means factorial 8 by factorial 2 factorial 6, and 7C2 will give you and this also you can calculate. I need not to waste my time, because this is very easy. 7C2, how will you calculate 7C? 2 factorial, and this is 5 factorial. So if you reduce it, I will get 8 into 7 by 2 here, and this is 7 into 6 by 2 here. So 2, 4, 28, and here you will get 3, that means 21. So all total you will get 28 upon 49, isn't it? So this will be, now you further can reduce 7, 4, 7, 7, so that means 4 by 7 will be your result. Understand? So next problem is problem number 33. It says, let E and F are events of an experiment such that the probability of E, that means event E is 3 by 10, probability of event F is half, and probability of F, happening of F when E has already happened, is 2 by 5. Find the values of 3 conditions are given. So one by one we will do. So first of all, we will put the formula in terms of F and E. Now if I want to calculate F E, this is just F intercept E and by probability of E. This is the orientation of any two events that is interdependent, where one event has already happened and other events yet to happen. So we want to get the result of that event that is yet to happen. So probability of F in E is being given that. Now also we have said the probability of any the intercept, whether it is F intercept E or E intercept F, if it is in a sample space and interlinked or interrelated, then both the values are same. So we can also write it like that, E intercept F, and the remaining will be same. So now in the first problem it is E intercept F, this has to be calculated. So those that we also can write E intercept F as is equal to F in E into probability of E. So we know the values. F and E means intercept is 2 by 5 and probability of E is 3 by 10. So this will give you 3 by 25 for the first one. So the second one, it is P E by F, just the reverse of that we have already get. So this is also the same. If I go ahead, E intercept F by probability of F will come here. So E intercept F and F intercept E are same. So we can put the value of this that we have achieved here in the first part. So this will be 3 by 25 and probability of F is already given, half. So this will give you 2 will go there, 6 by 25. So second part is also done. Third part is probability of EUF, means this is, now I have to explain it in the Venn diagram first. Now in a sample space, if I see two events E and F which are interlinked, let's say this is E and this is F, so this part we are saying intercept, means E intercept F or F intercept. And if we see the E union, this is said to be union. Union means all together space. That means the F and E, when they are being intercepted, so that EUF means the area belong to F, area belong to E, and their common space. Now when we add up F and E together, so this common space comes twice, because one for this area, one for this part, and one for this part. So if 2 is coming and I want to get the space, this intercept and plus this the remaining of E, then what you have to do, you have to add these two together, and if you subtract one of the intercept, then that is similar to the space, the F remaining leaving intercept, E remaining leaving intercept plus the intercept, that will give you same. So I mean to say the F union E or E union F both the same. You can write it E union F are same. This will give you by F plus E minus E intercept F, or the other way, F E minus F intercept, sorry, this will be intercept sign, I made mistake, F or F intercept E, both are same. So now likewise the probability of also we can write it in the same manner, probability of F, probability of E, probability of this, or probability of this, probability of this, or probability of this, both are same. Now you know the values, probability of F when we are calculating E union F, E union F or F union E are the same. Probability of E union F will be given as probability of E. So probability of E means 3 by 10. Probability of F means half. We can put interchanging the places also, there is no harm in it. And probability of F intercept E. F intercept E we already calculated for the first case, where E intercept F and F intercept are the same. So 3 by 25. So if you calculate, this will give you how much? 3 by 10. So this is 5 by 10, 8 by 10 minus 3 by 25. So this will give you 25 means, if we go for 50, this is 5, it's a 40 minus 25, 6. So that means 36 by 50, reducing I will get 18 by 25. So this will be the result here, 18 by 25 for the last part of that, where you need to get the probability of E union. This is said to be union F. Union means not the complete one, the remaining part except intercept, remaining part except intercept, and one part of intercept, that can also be achieved by getting both together minus one intercept. Understood? Logic you can understand easily, because this, if I make the area, this area plus this area plus one intercept is equivalent, if I add this plus this, then this part is coming twice. So you have to deduct once, because when you will add this part will be added with this. When you will add this, you will, one part is added to this, and if it is coming twice, you have to deduct once. So that is the intention. So this is problem 33 I have explained. I will end up here. In the next video I will start from problem number 34 in conditional sum and further to that. Okay, thank you for now.